Look around you for a moment. Everything you see, the walls, your phone, your body, the earth, the sun, is made of matter we understand. Atoms, electrons, protons, neutrons. This is the matter we can touch, weigh, and measure. But here is the uncomfortable truth. All of this familiar matter makes up less than 5% of the universe. The rest is something else. One of those missing components is called dark matter. Despite the name, dark matter is not evil, not dangerous, and not science fiction. It is called dark simply because it does not emit light, reflect light, or absorb light in any way we can detect. We do not see dark matter directly. We see its gravity. Gravity never lies. When astronomers looked at galaxies rotating, something strange appeared. The outer stars were moving far too fast. According to known physics, those galaxies should have flown apart, but they didn't. Something invisible was holding them together. That invisible mass, 5 times more abundant than normal matter, is what we call dark matter. Dark matter forms a massive, invisible halo around galaxies. It acts like a cosmic skeleton, giving galaxies their shape and stability. Without dark matter, galaxies like the Milky Way would never have formed. Stars would not have gathered. Planets would not exist. Neither would we. And yet, we still don't know what dark matter is made of. We know what it does. We know where it is. But we don't know what particle or particles create it. And that mystery brings us to another strange resident of the universe. A particle so elusive, it passes through your body by the billions every second, without you ever noticing. These particles are called neutrinos. Neutrinos are real, well-studied, and proven to exist. They are not hypothetical. They are born in some of the most violent places in the universe. Inside the sun, inside exploding stars, inside nuclear reactions. When a neutron changes into a proton, an electron is released. And something else must be released too. That something is a neutrino. In physics, nature loves balance. Charge must be conserved. Energy must be conserved. Just like a positive and a negative cancel to zero, neutrinos carry away what would otherwise break the rules. They have almost no mass, no electric charge, and they barely interact with anything. That is why they pass straight through the Earth, through oceans, through your bones. We can detect them, but only with massive underground detectors. Deep ice, deep water, deep silence. Now here's where things become interesting. Dark matter and neutrinos share something in common. They both barely interact with normal matter. Recent research suggests that dark matter may interact weakly with neutrinos. Not proven, not confirmed. This is still under investigation. Science moves carefully, not emotionally. If such interactions exist, They could explain why dark matter remains invisible, why it slips through detectors, why it hides so well. Neutrinos show us that the universe allows particles that almost never interact. Dark matter may simply be another example. Heavier, slower, and far more abundant. This does not mean dark matter is made of neutrinos. That idea has been tested and ruled out. But neutrinos prove that invisible matter is physically possible. And that alone changed cosmology forever. Our senses evolved to survive on Earth, not to understand the universe. Reality is not limited to what we can see. Dark matter remains one of the greatest open questions in physics. Neutrinos remind us that mystery does not mean magic. It means discovery is still happening. If this helped you understand the universe a little better, take a moment to like, comment, and subscribe to AstroNerd. Your curiosity keeps science alive.